Welcome to the project demonstration of advanced Footstep power generation system with RFID for mobile phone charging applications. The main application and the features of this project is in public areas we are going to place this kind of piezo plates. So this piezo platform consists of 9 piezo plates. In that 3 are in series. So these kind of sets are connected in parallel. Total 3 sets. Total 9 piezo plates are connected in 3 by 3 manner. So 3 are in series and 3 sets are in parallel. The output of these piezo plates will be given as input to the charging circuits of this battery pack. And directly we can charge a battery using these footsteps. When we are applying a force on this, all the piezo plates will get the same force. Then only the voltage will be converted into like pressure to the DC volts, and that is input to this battery pack for charging purpose. So we can place n number of footsteps, and whenever we place these in a public area, when we are walking on this platform, then the voltage will be generated, and we are going to store that. And in the same area for authentication purpose, so instead of charging a mobile phone or charging a laptop, so in our project we are demonstrating that with mobile phone charging application. So only authenticated persons can access this charging unit. By using the RFID, we are going to providing the authentication. Near this RFID reader, when we show the RFID tag, the so-called stored energy will be given to this mobile phone charging unit through this electromagnetic relay. So for converting the 12 volts DC to 5 volts of DC, we are making use of this LM2596 voltage regulator. So from the power generation to the storage, and from the storage to the utilization based on authentication. So these are the main features of the project. To execute these features applications, we are making use of main components. One is a power source power generation unit, piezo plates, and which was connected parallel to the microcontroller to measure the generated voltage display on the LCD screen, and parallelly connect to this battery pack. And the battery pack we are using 12 volt to 1 amp. So in this battery pack we can see 3 4 volt 1 amp batteries are in series. So we'll get 12 volt 1 amp DC output. So the 12 volt 1 amp DC output is connected in series with the relay to this LM2596 voltage regulator, which is used to convert the 12 volts DC to 5 volts of DC. As the operating voltage of our mobile phone charging unit is a 5 volt. So the 5 volts DC directly input to this USB converter. So from there directly we can charge multiple mobile phone chargers cable directly. And here authentication purpose we are using EM18 RFID reader module, and this is a step down transformer. Whenever there is no sufficient power is generating from this one, we can charge this battery pack with the help of this transformer, and we can run the circuits. And here this is the charging unit. So either from the transformer or from the piezo plates. So parallelly it was given the input to this battery pack to this charging unit, and also it will provide the power supply to the whole system. So 16-bit LCD will show the status of the project. So coming to the interfacing circuit diagram connection. So LCD interface gets pin number B2 to B7, C3 interface to the relay, B0 for this EM18 RFID reader module. So let us see the demonstration. So on the power supply to the sketch, welcome message displayed on the LCD screen, and then after waiting for the tag. So when we show the tag here, so if the tag authenticated, and then the timer started, because we are demonstrating for timer based charging unit, and it will be charged for that 60 seconds of duration. Right, once again see that, show the tag. So there we get the batteries mobile phone getting is charging. So meanwhile we can apply that to check the voltage availability. So we can apply the force on this one. We can see the 5 volts is generated. So slowly apply the force. Right, we can see the voltage is generating, displaying on the LCD. Right, okay. So in this manner the voltage is generated from these piezo plates by applying the force. So if you apply the same force on equally on 9 piezo plates, then the voltage can generate up to 15 volts. So when we get in the same force on the each and every piezo plates, because they are connected in series. So piezo plate nothing but which is a transducer which can take the power and which can generate the power. So when we provide the power supply to that, which will act as a consuming the load, which will act as a load, and when we apply the force on that, it will acting as a source to generate the voltage. Right. Once the timer completes, then automatically the relay gets switched off.